Now we're getting into Appendix B. Now Appendix B is the time value of money. So what happens here is the fact that money, because of interest, increases in value as time goes on. So let me start out with an example here. So here we have, this is a $1 and it's deposited at 10% interest. And 10% interest, I'm using it for illustration purposes because it's easy to work with. So here we have now, here we have 1 year, here we have 2 years. Okay, so I deposit $1 now. Okay, now $1 times 10% is 10 cents. So between here and here, there's 10 cents of interest. Okay, and I add back my original $1, and so now this $1 has grown to $1.10 after 1 year because you added the 10% interest. That sound pretty good? Okay, now it's $1.10. Multiply that times 10%, it comes out to 11 cents. Okay, so now there's 11 cents of interest. And I add back the $1.10, and here's where I'm getting at. And so now it's increased to $1.21. So $1 now is worth more than $1 in the future. Okay, because $1.21 is the same as $1 2 years in the future at 10% interest.
So it's like compound interest?
It is compounding interest, and because what you're doing is you're paying, you're absolutely right, Cameron, you're paying interest on interest.
Right.
And so here you have 10 cents worth of interest, and there's a penny's worth of interest on it. There was 10 cents of interest the first year, 11 cents the second year, so now $1 today is the same as $1.21 2 years in the future. Okay? And so $1 today is worth more than $1 in the future. This $1 in the future is $1.21. Okay? And this is a lot more powerful than you think, because if you, there's where I put it, if you project this into the future, it's called the miracle of compounding. So in this case, I'll put this up here. So in this case, what happens on this thing is, if you deposit $1 today, and let me turn that camera around so our viewers at home can. So if you deposit $1 today, and it compounds, here's how it grows in value. So what happens here now is when you deposit the $1 today, which is right here. So here's the number of dollars, here's the number of years, right? So here's $1 today. And it grows to $45 if you leave it in there for 40 years at 10%. Sound good? So, and it just keeps growing like that. All right, because all they did is just leave it in there. All right. Now, so what we're going to do is let's work with this. So what we've done on this thing is, rather than require everybody to buy the same calculator, etc., we're just going to use tables. And tables do the same thing as a calculator, just that everybody will have, rather than everybody either buying a calculator or whatever, we'll just use the tables. Plus, you develop additional skills using the tables, right? So, here's how this works. So what happens here is, and you be sure to write this quadrant down because this isn't in the textbook. Sometimes you have a single amount, sometimes you have an annuity. Okay? So a single sum is like what we have on the board. It was $1, they put in one time and it grew, right? An annuity would be like every month you're going to put $100 aside to buy a new car. It's the same dollar amount after the same period of time. Here's how I'll do this at equal time intervals. How's that? Is that more sophisticated? Okay, so an annuity is the same dollar amount at equal time intervals. So you put $100 into your account every month. Okay, same time period, month, same dollar amount, $100. Now sometimes we're going to look for the present value. And this is the present value. So the present value of $1.21, 2 years in the future at 10% interest is $1. And the future value of $1 at 10% over 2 years is $1.21. And sometimes we'll look for the future value. Okay, does that sound good? So sometimes we're going to look for the future value. In other words, if I deposit $1 in an account that pays 10% interest, what will it accumulate to? Or if I need $1.21 2 years from now, how much do I have to deposit now at 10% to prove that? And the answer would be $1. So here we look for the present value. So sometimes we'll look for the present value, sometimes we'll look for the future value, sometimes it'll be a single amount, sometimes it'll be an annuity. Okay, this is a single amount. Okay. All right, sound good? All right. Now, there's 4 tables. So table 1, and I'll write the word table here, but okay, table 1, and you find these in Appendix B. Here's what it looks like. On page, it's 794 or B10, depending on what the version you're using. Here's table 1. And table 1, what it's looking for, I'm going to turn that camera around. So what it's doing now is table 1. Ooh, I never turned the camera back here. Just for our viewers at home, let me quickly go over this to repeat it. So don't forget, sometimes we're looking for a single amount, sometimes we're looking for an annuity. An annuity is the same dollar amount at equal time intervals. Sometimes we are looking for the present value, sometimes the future value. In this scheme of things, the $1 is the present value, the $1.21 is the future value. So the present value of $1.21, 2 years in the future, is $1. So in other words, if I deposit $1 in an account that has 10% interest, what will it grow to in 2 years? So I'm looking for the future value. Or if I need $1.21 in 2 years, and I can put it in an account that pays 10% interest, how much do I have to deposit today? That's the present value. Okay? And again, we're going to use the tables. So here is the table that we're going to be using. So this is found in Appendix B. We're going to start with table 1. And table 1 is when I have a single amount and I'm looking for a present value. Okay? So, let me turn off the light so it's more readable. And I'm going to use something a little different just because it's easier to work with. So, what I did is on the test and everything, I just Xeroxed the tables that we have in Appendix B. So, and the reason I think that's a good idea is because when you take the test, you'll be working with the same tables that you worked with all along. Okay? So I'm going to put this over here as kind of as a reference. So, let's do this. Let's take a look at, as an example of using table 1, let's take a look at quick study B4, and we find that on page B7. We find that on page B7. So it's found on page B7, it's quick study B4. Here's how it reads. So what it says is, so here's B4, okay? So the Flaherty is considering an investment. If paid immediately, is expected to return $145,000 5 years from now. Flaherty demands a 9% return. How much is she willing to pay for the investment? Okay? So, the way the table works is, the 9% will be in this column. Okay? So here's the rate. It's a 9% rate. Now, the way it's worded here, it sounds like she's demanding, what it means is the fact that she can shop, if she shops around, she can find something that'll pay her 9%, okay? And it seems like an outlandish number at this point in time, but in my lifetime, you could get an investment that would pay 9%, this maybe 30 years ago. Yeah, but, okay, all right. And then, over here are the number of compounding periods. Well, it compounds annually, so it's 5 years, so there's 5 compounding periods. So the factor is 0.6499. So here's how this works. Okay? What I do on that is, we're talking about $140,000. Let me do this. So it's B4. So we're talking about $140,000. I'm going to multiply that times 0.6499. That means that if I deposit $90,000, she deposits $90,986 today. In 5 years, at 9%, it will grow to $140,000. And again, what I did is I used table 1 because it's a single amount. Okay, it's a single amount, and I'm looking for the present value. Okay, does that sound good? So what it says is if she wants $140,000 in 5 years, she deposits $9,986 today at 9%. It would grow to that. And where I get the factor is the column headings are the rate. It's a 9% rate. Across the last column are the number of periods, which determines the row. And so the factor is 0.6499. Here's where I'm getting at. Everybody okay with that? Okay. Now, let's take a look at another one of these. So now if we do this, I'll get my notes here. So now, let's go back to the grid. So we had a single amount. We were looking for the present value. And we used table 1, right? Now, let's change this. Again, we have a single amount, but now we're looking for a future value. So we're going to use table 2. And table 2 is right below it. Okay, so table 2 is the future value of $1, just like table 1 was the present value of $1. So it's each dollar. So let's put this up here for the moment. Let's take a look at quick study B5. And you find that on page B7. Here's how it reads. What it says is, okay, down here at the bottom, what it says is, I'm going to make this will lay better if I fold it in half. So here's B5. So what it says is, C2 Incorporated invests $630,000 in a project, expected to earn a 12% annual rate of return. The earnings will be reinvested in the project a year. That means they don't take the earnings out, they just leave them there. Okay, so it compounds. Each year until the entire investment is liquidated in 10 years. What will be the cash proceeds? So, what it says, if they invest $630,000, they expect the project to have a 12% annual return. Maybe they're getting that off of the income statement. The net income would be that. It's supposed the net income, and suppose they leave it all there. How much will it grow to in 10 years? So what it is here's the present value. What we're looking for is the future value. So we have the present value. We're looking for the future value. So we're going to use table 2. All right? So in this case, it's 12%. So that will mean it'll be in this column. And there's 10 compounding periods, because it compounds annually. So that means the factor, let me make sure I line these things up right, I am. That means the factor will be 3.1058. So, I'll put this here, and this is B5. So, $630,000 invested today. Here's the factor. Will grow to $1,956,654 in 10 years at 12%. So this is what we're looking for, is the future value. This is what we're looking for. Here is the present value, and then here is the factor, and the factor came off of table 2. Okay? Does that make sense? Now, let's take a look at another one. So let's take a look down here at an annuity. Okay? And of course, an annuity is the same dollar amount at the same time interval. All right, so we're going to use table 3 if we want to find the present value. So let's take a look at it. So in this case, what we'll use here is we'll take a look at table 3. Table 3 looks like this. Okay, so here's table 3. So table 3 now is the present value of an annuity of $1. Okay, and this is table 3. So let's use let's use quick study B6 as our example, and you find that on page B8. Okay? So here's how it reads. Here's B8. Okay? So here's how it reads. What it says is, B6, right? Yep. All right, so what it says is, the Byrne Distributing is considering a project that will return $150,000 annually, all right, at the end of each year for 6 years. If Byrne's demands an annual return of 7% and pays for the project immediately, how much is it willing to pay for the project? So what it means is, every year, you expect to get $150,000 for this project. What's the present value of that annuity? It's the same dollar amount after the same period of time. What's the present value? If you were offered this, how much would you pay for this offer? Okay? So, in this case, it's 7%, so that'll put it in this column. And it's 6 years, so that'll put it in this row. Okay, let me make sure I do have everything lined up there. So the factor then is right here, 4.7665. So in this case, here's what we'll have, okay? So what we'll have is we'll have 150,000, so this is the annuity. The factor is 4.7665. So the present value of all of that future cash flow is 714,975. So if you pay less than this, you will be ahead. If you pay more than this, it'll be a money loss. Okay? And again, what we're looking for is the present value of a future annuity. That's why you use table 3. Does that make sense? Now, let's take a look. We're looking for the future value of an annuity, and so we'll use table 4. Now, you guys have probably figured out the trick to succeeding in this chapter is just deciding what table to use, and after that it's just plug and chug. Okay? So what I'm going to do is I'm going to demonstrate how to use the tables, and then we'll do practice. And it just, if you know what table, if you can figure out what table to use, you got it. Just plug and chug. Okay? So, but let me show you an example of what the use of table 4 looks like. So for table 4, we'll do quick study. We do quick study B7, and you find that on page B8. Here's how it reads. So what it says is, Claire Fitch is planning to begin an individual retirement program in which she will invest $1,500 at the end of each year. Fitch plans to retire after making 30 annual investments in the program, earning a return of 10%. What's the value at the day of the program? So she hopes to retire in 30 years. To that end, she's going to put $1,500 aside at the end of each year. Okay? So what we're doing is we're looking for the future value of this annuity. And we're going to use table 4. So here's table 4. Okay, let me fold that in half so it lays a little better. So in this case, it's a 30 years, so it'll be the pretty close to the bottom here. Okay, so here's 30 years, and it will be a 10% return, so it'll be in this column. So the factor will be 164.4940. So here's what that looks like. So the annuity is $1,500. The factor is 164.494. That means the future value of that annuity will be 246,741. So if she puts $1,500 aside each year for 30 years at 10%, here's what it will grow to. So here's the annuity, and here's the future value. Okay, and this is table 4. And it's an N of 30, and there's 30 compound periods, and an interest of 10%. Now, the interesting thing here is the fact that what she does is it's $1,500. She makes 30 deposits, so she'll actually deposit $45,000, right? So it's $1,500 every year for 30 years, and that $4,500, because of compounding, will really accumulate to $246,741. So here's the actual dollar amount. Here's what it accumulates to, which is surprising. Okay. All right. Okay, so you guys doing good? Why don't we do just a little bit of practice? Well, actually, let me show you one more thing. Okay. So is everybody? So again, in the most part, you just decide what table to use, and after that is plug and chug. Let me do one thing. Let me go to. Let's go to quick study B1. and you find that on page B7. And why don't I do 1 and 2, and you guys do 3 and 4? So here's how it reads. Here it is. So here's how it reads. So what it is here's I'll put it over here so you just refer back to it. So what we have here now is quick steady B1 is right here. Okay. So in this case, what we have is I'll show you how this works. So let me do number 1. Okay. So assume that you must make future estimates using the future value table B22. Which interest column do you use and what's the rates? So it's 8% compounded quarterly. Okay? So what this means is if it's 8% compounded quarterly, what that means is you have 8% compounded quarterly, so that means that it's 2%. The way the convention on that is it's 2% every compounding period. And it's going to put it in there for a year, I suppose. So if it's in there for a year, there'll be 4 compounding periods. So you'll have an N of 4 and an I of 2%. So what that means is, does that make sense? So when they say 8% compounded quarterly, what that means is every quarter it'll garner 2% interest. And if it's left in there for a year, you'll have 4 compounding periods. So that means you'll have an N of 4 and an I of 2%. Is everybody okay with that? The next one, let me do the next one. 12% compounded annually. Well, 12% divided by the number divided by 1, it'll be 12% per compounding period, and there's 1 of them. So here you have an N of 1, because it is 1 year, and an I of 12%, because that's the rate in that 1 compounding period. Sound good? All right, why don't you guys do 3 and 4? So it's 6% compounded semi-annually. Semi-annually means every 6 months, 12% compounded monthly. So for number 3, it's 6% semi-annual. That means it's 3% per compounding period. There's 2 within that year, and we're only doing a year. So you'll have 2 compounding periods at 3% per period. The next one is 12% compounded monthly. So 12% divided by 12 months, 12 compounding periods within a year, is 1% per compounding period. And there's 12 compounding periods within the year. So we have an N of 12 and an I of 1%. You guys okay with that? All right, so let's do this. Let's do some practice. Okay? Now, let me put this problem up. and it will involve the use of these tables. And you know what I think would be the best? If you guys want to work with people sitting next to you, I think it just moves along. It's the best way to learn it. Okay, does that sound good? So let me put this problem up here. So in this case, the Sarah Blue, okay, Sarah, she won the lottery. And of all things, the lottery says, you got 3 options. Tell us what you want, okay? So first option number 1 is you can receive $1,000 per year for the next 10 years. Okay. Option 2 is you can receive $6,000 cash immediately. Or option 3 is you can receive $10,000 cash after 5 years. Okay, so in this one, $1,000 per year, you'd have an annuity. Here you have $6,000 cash immediately, or here you can have $10,000. Now, the secret to working this, of course, is you want to compare apples to apples, oranges to oranges. So what you want to do, if you find the present value of each of these options, you'll have made a common denominator, like APR, annual percentage rate. Does that make sense? Christian, I don't really know. Does that make sense? Yeah. So find that if you find, and then the one with the highest present value would be the best choice. Now, alternatively, you could have also found the future value of all 3 of them. That would have worked. Let's start with the present value. Okay. So we have an annuity, a single sum, Now, I turned the camera off, so we don't have a bunch of blank tape under, but this is the end of a long week, and odds are I would forget to turn it back on, so I'm just going to leave it on. Candy, you look lost. You doing good on this? All right, okay. Oh, yeah? All right, good. So, and you guys do talk, let me turn on the lights so you can maybe converse with a neighbor. And I think it's a good way to learn if you talk it through. So let me turn on a light. I don't think that won't screw up the camera. Yeah.
The second one is receive 6,000 cash.
You receive $6,000 cash immediately. So you go down there and they give you a $6,000 check.
Okay, and the third one receive 10,000 cash after.
And at the end of 5 years.
Do you make this problem up or is it in the book?
I don't know where it came from. I accumulated something over the years. And I don't really know where it came from, actually. In fact, I should make sure I give people credit, shouldn't I? You know what? Come to think of it, it did come with the book. It was in the lecture notes or something. It does come with this book, and it's with the lecture notes. That's where it did come from.
This wisdom pulled from the ether.
No, it didn't come from the ether. This one I think did come from here. And if you guys are at home, don't forget, just fast forward through these silences.
So you want to collect.
Sure, if you, Serena, I'm not sure what you're saying, so go ahead, work all three, I'll give you feedback, which of the choices would you make? And of course, the answer to that question is, which will give you the greatest value? So you can find the present value of all three choices, the greatest present value will be the one you choose, or you'd end up with the same conclusion if you found the future value of all of these, but let's start with the present value. Does that
What's
sound
the
good?
rate?
Yeah.
What's that?
I'm confused
Oh,
on the rate.
10% rate.
Oh. It's like,
I just did a thing where I assumed we already knew, and I wasn't paying attention, so I was just gonna sit there and wait until we got the answers. It's already,
I just
Sorry.
I knew I couldn't be the only one thinking of that.
I was like, okay.
I was like, it depends
I was
on-
wondering,
No, I was
listen, you
going
guys
through
are
trying
really
to
sharp,
find-
and for some reason, I didn't see any movement here, and I thought, and then he says, we'll talk it out among ourselves, maybe that will break the stalemate. Is that what you were wondering, Serene?
Everyone's afraid to admit that they don't know the interest rate either.
Okay, all right, Serene?
So find the present value for all of them.
Yeah, find the present at 10%, yeah,
Okay.
yeah, sorry. And by the way, guys, I just forgot to write that down, sorry. But it's at 10%. Hey, but listen, it's okay, because everybody reviewed and thought it through, and that's the best learning experience you'll have this, you know what I mean? It was wonderful. So did you guys get $6,145 for the first choice? I'll print this out. Is that what you guys got? All right. What's the present value of the second choice?
6,000.
It is 6,000, okay? Okay. And then how about the next one?
6209.
Is it 6209? Let me just take a look here. It is 6, okay, yeah. All right, so the next one is B1. And it will be $10,000 times 0.6209 and $6,209. So, if you were given these options, this would garner the most interest. This would be the best choice. And all you did is you just find the present value of each, right? Now, is everybody okay with that? Okay. Now, let's go the reverse. Why don't you find the future value of all these choices? Now, by the way, this number 3, it may be a little bit tricky for the future value. Because don't forget, this is after 10 years, but this is only 5. So, it'll be a little bit tricky, but I'll show you, okay. that number 3, you receive the cash in 5 years, but what's the value of that 10 years in the future? You receive it in 5, but what's its value at the end of 10? So did you get $15,937 for the first option? Is everybody okay with the first option? And again, 3 is your better choice. And on number 3, you receive it in 5 years, but you want everything at the end of 10 years. So in effect, you received 10,000 at the end of 5 years, but you kept it for an additional 5 to compounded interest. So in 10 years, this $10,000 will be worth $16,105. Does that sound good? Sound good? All right. So, you doing good? Okay. So let's do this. Let's, any questions, comments on that? All right, let's do some practice now. So, what I'm gonna do is let me just take it. So is there any questions on this? You guys doing okay? Here's the answers. Make it a little more legible. This is a demonstration problem from Appendix B. These are just my notes.